But in chapter 1, they kind of put all these little review sections in there of things that you've sort of talked about, but maybe there's extra stuff in it. So if you think about that, in most of the sections, there's probably been something you've heard before, but then there's been stuff maybe we haven't heard before. And that's the way it is here. So can you guys remind me with transformations, what does it mean to reflect something? If you do a reflection, what are you doing to the object? Kind of. I can see where you would think that. It flips over. Very good. So you might have heard it as the word flip, but we're going to call it a reflection. When you rotate something, what do you do to it? So what is that? Turning it, okay? And then what happens when you translate a shape? You move it, so you're sliding it left or right, up or down. So hopefully you have heard those words before, flip, turn, and slide, but we're not going to use those words. We're going to use reflection, rotation, and translation. And this section is just really a big overview of transformations, taking a shape and translating it, taking a shape, reflecting it, taking a shape, and rotating it, okay? Raise your hand if you have seen or done that in previous math class. All right, so it should be somewhat of review, but again, there's going to be some picky things that I'm going to be picky about and just some new things that maybe you haven't seen before. Our last 6 vocab words of our 50. This first little part here is just kind of FYI. You can read that if you want to. It's just kind of an example of where you might see transformations, but we're going to jump right into our vocabulary word, transformation. Be careful that you don't confuse transformation with translation. Those words are so close, it's easy to read over it and confuse them. Transforming is the big broad category. You're taking a shape and you're going to transform it by either reflecting it, rotating, or translating it. So a transformation is where you change the position of your shape. We will not change its size today. There is a transformation that does change a shape size. It makes it bigger or smaller. Does anybody know the name of that transformation? Dilation, very good. So a dilation does increase or decrease your shape, kind of like your pupils dilate. They get bigger or smaller, but we're not going to do dilations until later in the textbook. So our shapes will not change size. If yours gets bigger or smaller, you've done something wrong today. It will not change the shape of it, although a transformation can change the shape of your figure. All of our transformations in the entire course of geometry will not change their shape. If you start with a triangle, you're going to end with a triangle, okay? The original figure that they give you is called the pre-image. The figure you get after you've transformed it is called the image. So pre-image is what you're given, image is what you get. Okay, this next little part is super important because most of the time my students tell me that they have never really seen it this way before. So really pay close attention to this last little paragraph. A transformation maps, so we're going to use that word maps. A transformation maps the pre-image onto the image. What that means is if I have a triangle here, A, B, C, and I reflect it across this line, I'm going to get this new triangle. What is this point going to be the same as? C, because it's going to flip over. So we're going to call that C prime. We're going to call this B prime and this A prime, okay? So when they say it maps onto, what they're saying is that point A maps onto point A prime. It's just what it lands on top of, okay? So it is the new point after the reflection. This is your pre-image, this is your image. They should be the same size. I did a terrible job of drawing them. Pretend they're the same size. But the reflection is mapping one shape onto the other. That's what that means, mapping. The other thing that I mentioned there is the prime notation. Most of the time you're going to use prime notation. If you take this shape and you do another transformation, maybe you take this shape and you slide it down so that you've translated it, and you get this new triangle down here, this point would be called C double prime, and this would be B double prime, and this would be A double prime. Okay, so prime just indicates it's the image after the transformation. They're also going to ask you to use what's called arrow notation. This is super simple. Ronnie, stay with us. You can stand up if you need to at the back, okay? But just try not to fall asleep. I know it's early and we're tired. I get it. Okay, so arrow notation should be really easy, but it always confuses my students because it's kind of not necessary. But I want you to understand that they're going to ask you for it. You're going to need to know what it is. Arrow notation is just simply where you name the pre-image and the image with mapping notation. I'll show you what I mean. Okay, so arrow notation is just simply where you name the pre-image, triangle ABC. You use an arrow, that's why it's called arrow notation, and that means it maps onto. So if you were to read this mathematically, you would say triangle ABC maps onto triangle A prime, B prime, C prime. You just name the new shape that you get after the transformation. So this right here is called arrow notation. So in the book, if it says list the arrow notation, that's all they're asking you to do. Okay? This is in your notes. If you look at this next page right here, we have our pre-image. We have our image. They're using an arrow to show you what's happening to the shape. What kind of transformation would this be? A translation. So in this picture, we see a translation. We have a pre-image, we have an image, and then notice that on the image they've used their prime notation, and then this right here is the arrow notation. So you may want to add arrow notation in your notes right here, so you'll know whenever you go to the homework, that's what they're talking about. If they say write the arrow notation, as simple as just naming the two shapes. The only shapes that we will put a symbol in front of are triangles and parallelograms. And right now we haven't even talked about parallelograms, so you don't really have to worry about that. If it's any other shape, like let's just say you have a random quadrilateral. Okay, it's not really a special shape of any sort. Then you will just use capital letters to name your shape using your 4 vertices. So to name this, I could say A, B, C, D, but I don't put a shape in front of it. Okay? What you cannot name this, you cannot name it A, B, D, C, because then that would not create the shape, right? So make sure that you always go clockwise around your shape when you're naming your shape. Okay. So here are our 3 transformations. Now I want to make sure that you are super clear for the homework. If they give you a picture like this and they say, what transformation is this? All you have to tell me is reflection, translation, or rotation. That's it. No specifics, no details. If it looks something like this, it's not on graph paper, it's just a picture. You're just going to list one of those 3 transformations. Are we clear about that? Okay. If it's on graph paper, if it's on a coordinate plane, if they give you coordinates for the vertices and you could get graph paper and graph it, then I'm going to ask you to give me some specific details, and I'm going to be really picky about this. Take good notes right now, okay? If you look at the picture, it's on a coordinate plane. So this is when it's on a coordinate plane. When you're on a graph. If it's not on a graph, you just have to tell me what it is. Reflection, translation, rotation. If it's on a graph, I'm going to expect more detailed information. So first we'll start with reflection. A reflection, which we know is called a flip, but we're not going to use that baby word anymore. We're going to call it a reflection. A reflection is a transformation across a line. That line could be the y-axis. That line could be the x-axis. That line could be a diagonal line. That line could be a horizontal line somewhere else other than the x-axis. It could be a vertical line somewhere other than the y-axis. But it is across a line. That line is called the line of reflection. To do a reflection, what you're going to do is identify what is my line of reflection. So notice here the black line is our line of reflection. And then you're just simply going to count the distance from your pre-image point to the line. So for example, if this was 2 units, then you would count 2 units on the other side of the line. And that's where your C prime would go. Does that make sense? And that's how you can do every reflection. Count the distance from your pre-image to your line, line to your image, graph your point. Okay. Yes, sir. So they will give you enough information that you know exactly where that coordinate is. They'll either give you the coordinates so you know that it's at like 1, 2. They'll give you enough information that you know. If it's at the halfway point, it'll tell you it's at 1.5. So you can at least count that. Let's say this was at 2.5, then you would go 2.5 units across. Okay, but they will give you. They won't just give you a picture where it's not evident where those coordinates are. Is that what you're asking me? Okay. Let me know when we do some examples if it doesn't make sense. Okay, so what I'm going to ask you to also tell me, besides it's a reflection, if it's on a coordinate plane, you have to identify the line of reflection. So if it's on a graph, you have to tell me what is the line that it is reflected about. Your answer would be reflection across the line blank. Reflection across the y-axis, reflection across the x-axis. So let's review some Algebra 1 real quick, because this is what a lot of students mess up on. Okay, we already talked about this. Horizontal is your x-axis, vertical is your y-axis. What is the equation of this line right here? This vertical line that's going through 1. What is the equation of that line? Say it again. Okay, it's not y equals 1, but that's the most common mistake that I get, because it's vertical and you think the y-axis is vertical, so it should be y equals 1, but it's actually x equals 1. And here's how I remember it. See if this helps you. When I have a point on this line, it's at 1, 1, 1, 2, 1, 3, negative 1, 1, or excuse me, 1, negative 1, 1, negative 2, 1, negative 3. What variable is always at 1? X. X is always at 1. Y is constantly changing. Does that make sense? So the equation of this line is x equals 1, because x is always 1. So if you have a vertical line, it's always going to be x equals. What would the equation of this line be? If this is 1, 2, 3. Y equals 2. Again, notice you have a point at 1, 2, 2, 2, 3, 2, but it's the y value that is always going to be 2. So the equation for this line is y equals 2. So if you don't know that, I would make myself a little note on my paper right now. If it is a vertical line, then it is always going to be x equals a number. If it's a horizontal line, it's always going to be y equals a number. Because you're going to have to tell me it's a reflection across, and then you're going to have to tell me what the line is. If it's not the x-axis or y-axis, you're going to have to give me the equation for that line. Does that make sense? Okay, so if it's horizontal, it's going to be y equals. If it's vertical, it's going to be x equals. Okay, so if it's on a coordinate plane and you notice it's a reflection, you're going to tell me it's a reflection across whatever line it is. Moving on to rotation. Rotations, we already know them as a turn. They are a transformation about a point. When you tell me it's a rotation on a coordinate plane, you have to tell me what is the center of the rotation. That point that it's rotating about is called the center of the rotation. When I look at this picture, what is the center of the rotation? Point P. But you only have to do this if you're on a coordinate plane. So you're going to tell me rotation, and then you're going to tell me about the point. You're going to be specific. What point? Remember that point's called the center of rotation. So you're going to tell me what is it rotating about. This is going to be really easy for this first lesson, because every rotation that we do on graph paper will be centered at the origin. So you won't even have to wonder, where is my center of rotation? If it's on a coordinate plane for this section, all of our rotations will be centered about the origin. So the first thing you're going to tell me on all of these will be, it's a rotation about the origin. Okay, and remember the origin is 0, 0, right? Okay, they'll get harder later this school year, but for right now, it's just always going to be about the origin. Okay, the second thing you're going to tell me is the direction that you're rotating. You will not use words like right or left. So what do we say when we're rotating something? What are our two directions? Clockwise and counterclockwise. So you're going to tell me what point are we rotating about, the origin, and then you're going to tell me what direction that you're rotating. And again, you're going to use the words clockwise or counterclockwise. And if you forget, look at the clock. How is it rotating? Clockwise is to the what? Right, and counterclockwise then is to the left. Okay? So give me direction, give me the center of rotation, and the last thing you're going to tell me, if it's on a coordinate plane, is the angle of rotation. And this will also be easy because all of your angles on the graph for right now are going to be in increments of 90.
At this time, if you would send seniors last names beginning with the C, D to the theater at this time. Seniors last names beginning with C and D to the theater at this time.
Okay, so you're also going to give me the angle, and those are going to be in increments of 90. So you'll say rotation about the origin clockwise 90 degrees, or rotation about the origin clockwise 180 degrees, or 270 degrees. So it'll be an increment of 90 degrees. If it wasn't an increment of 90, here is how you could find your angle. And you can even do this on your paper with it being 90 degrees. You can take a pre-image point, like for example G, connect it back to your center of your rotation, and then connect it to the image point G prime. The angle that is created is the angle of rotation. So you could use a protractor to actually measure that if you needed to. I'm not going to ask you to do that. Ours will be on graph paper and they will be in increments of 90, so you won't have to do that. But if you're looking at it and you're not sure, is that 90 or is that 270? Take a point, connect it back to your center, and then connect it to your image. And that'll tell you whether that is a 90-degree angle or if it's going way around to 270, or if it's a straight line, so it's 180. Okay? So that's what you're going to tell me if it's a rotation. Moving on to our last one, translation. We're not going to say slide anymore. It is a transformation where all the points of the figure move the same distance in the same direction. So those are the two things you're going to tell me. You're going to tell me how far it moves and what direction it moves. So you're going to list the distance and the direction. So for example, when it's on graph paper, you may say something like, this is a translation right to up 3, because the figure has moved right to and then up 3. Does that make sense? Okay, and we'll practice. All right, so distance and direction is what you're telling me if it's a translation. Now we're going to look at some problems, okay? And I've tried to save us some time by going ahead and giving you the graphs of the pictures. Sometimes on the homework, though, it's going to give you just the coordinates, and you're going to have to make the picture. So make sure that you take graph paper home tonight if you don't have it in your binder already, okay? So notice this says identify the transformation. Are we on a coordinate plane? Is my picture on a coordinate plane? Yes, that means when you identify the transformation, if you say reflection, you have to tell me what's the line of reflection. If you say rotation, you have to list those 3 things. If you say translation, you have to list those 2 things. When it says identify, you have to give me all the specifics if it's on a coordinate plane. Okay? So when you look at this picture, first of all, which color is the pre-image? Blue. How do we know the blue one's the pre-image? It doesn't have the primes. When you see those primes, that's telling you that's the image. So they're asking you, how do you get the blue shape to land on top of the red shape? So do you see a reflection, a translation, or a rotation? It's just going to be one. So do you see a reflection, a translation, or a rotation? Okay, so if you're not sure, there's a couple of things you can do for your homework. Here's some advice if you get to the homework and you're like, I don't know what this is. Number one, you can either get a piece of patty paper if you have patty paper, or you can get some from me, or at home if you have wax paper, you can use it. You can take that piece of patty paper and you can, it'll be smaller because your paper is smaller, and you can trace your origin because that's your center of your rotation for all of your problems right now. You can trace your origin, you can trace your triangle, and then you can try rotating it about the origin and see, does it land on top of itself? If it doesn't, then you can take your shape and you can try sliding it and see, does it land? Or you can take your shape and try flipping it over and see if it lands. So you can check and see. And if you don't have something thin that you can see through, you can do it with regular notebook paper. You may just need to darken it with a pen or a marker. Okay? You said that you think this is a what again? Okay, it should be a rotation. If I take this shape, Jackson, do you see that if I take this blue shape and try to just flip it over, is it going to land if I flip it this direction on top of the red? Does that make sense? Okay, so we're going to take it and we're going to turn it, right? So this is a rotation. So it's about a point. So what that means is if you hold your pencil on this point and turn your paper, does the blue shape land where the red shape is? And that's another way you can look at it. Can I borrow yours, Carlos? You could physically take this paper and try turning your paper and see, when you turn it, does the blue shape look to be where the red shape is when you turn it one turn 90 degrees? Or again, trace it and then turn it and see, does it land on top of it? You're not going to give me two answers. It is just one, and I'll show you if we need to. I can do it on under the dot cam how it lands. Okay, give me 1 second. I'll come back to it. When it says identify the transformation, right now we're basic. There's only one transformation happening right here, but I'll show it to you in just a second. Okay. First, let's talk about the things you have to show me, or you have to list. So, what direction is this a rotation? We're trying to take blue and make it land on red. So, what direction are we rotating it? Counterclockwise. You're rotating it to the left, so that is counterclockwise. And how far are we rotating it? 90, 180, or 270? Okay, if you're not sure, again, this is how you can tell. Pick one of your points on your pre-image. I'm going to pick A. Draw a line that goes back to the origin. Then draw a line that connects the origin to A prime. That is your angle of rotation. Does that look like a 90-degree angle? It is. It's definitely not 180, which would be a straight line, right? So this is a 90-degree rotation. If you're really not sure, you could grab a protractor and measure it, but I'm telling you it will be increments of 90, 180, 270. What's the last thing you have to tell me? Direction, angle, and the origin. You have to tell me that it's rotated about the origin. So this is a rotation about 0, 0, or you can write the word origin, counterclockwise, 90 degrees. Okay, I'm going to show you how this really is just a rotation about the origin under the dot cam so you can believe me if you're still kind of not really sure. So again, take your patty paper, trace. If you're trying this at home or you're doing this on your homework, take something you can see through. Again, if you don't have patty paper, if your mom or dad has wax paper in the drawer, you can cut a piece of that off in the kitchen, or you can just use a regular piece of notebook paper, but you may have to darken your shape you're tracing underneath. Trace your origin, trace your original shape here. I would label your points because B has to land on B prime, C has to land on C prime, A has to land on A prime. Put your pencil at your origin and turn your picture. And do you see, mine slid just a little bit. Do you see that it does land on top of itself? Okay, so if you aren't sure, trace it. Trace it and then rotate it, but you have to hold your pencil at the origin if you're rotating. If you're not rotating and you're translating, then try just sliding your picture around and see, is there any way to make it land on top of itself by sliding? And there's not. Yes, let me get you that. If you think it's a reflection, try flipping your paper over and see, does it land on top of it if I flip it that way? Does it land on top of it if I flip it this way? And you'll see it doesn't. Does that make sense how you can use another sheet of paper? Okay, so worst case scenario, grab yourself a paper, trace it if you're not sure. Chris, did that make sense? Okay. Kind of blew your mind when it worked, huh? Yeah, so we're rotating about that point, meaning you're holding your paper at that point and turning the shape. Okay, let's try another one. Oh, I forgot the most important thing that everybody misses on their homework, so please look up here right now. What was the second part to this question? Then use arrow notation to describe the transformation. Remember what arrow notation is. It is just simply where you name the two shapes with an arrow. So you will look at the picture and say, okay, triangle ABC, arrow, which means maps onto, triangle A prime, B prime, C prime. That's what they mean by arrow notation. Okay, make sure you take good notes on that because I don't want you to miss points on the homework. That's so easy, and just leaving it off will be what causes you to miss points. So it's just naming the two shapes with an arrow in between, showing that you're going from ABC to A prime, B prime, C prime. Is everybody good? Okay, let's look at another one. Again, which shape is the pre-image? Blue one because it doesn't have primes. So you're asking yourself, how do you get from blue to red? I heard reflection. Does anybody think translation? Okay, got a couple who think translation. Why is it not a translation? The letters won't match up. Be careful. You could slide this blue shape onto this red shape. But what happens is E does not end up landing on top of E prime if you slide it. And when you're matching up your shape, your letters have to land on top of each other. So in order to get E to land on E prime at the same time that F lands on F prime, we have to take that shape and flip it over. Do you guys see that? Okay, so this is going to be a reflection. You were right there. What do you have to tell me if it's a reflection on graph paper? The line of reflection. So what line are we reflecting the blue shape across to get to the red shape? It is the x-axis, and if you're not sure, find the distance between two of your points, F and F prime, for instance. There's 2 units between them. That means your line of reflection has to go in between that 2 units so that they would land on top of each other. So halfway between there would be this line right here, which is your x-axis. Does that make sense? So reflection across the x-axis. Make sure I can tell the difference between your x's and your y's. Some of you are really bad about doing this, and it's hard to tell if you're giving me an x or a y. If I can't tell, I'll count it wrong. So make sure that I can see if it's an x or a y. Okay? Any questions on that part? And then we need to use our arrow notation. Thank you, Chris. So it also says then use arrow notation. So name your first shape. How do you want to name that blue one? Okay, I heard D, E, F, G. Thank you. Alphabetical is nice for me if it works. D, E, F, G, and then you put an arrow, and then what are we naming the next shape? Be careful, your letters have to match up. So where is D going to land? On D prime, right? So when you write this arrow notation, you're telling me where the points match up. So it should be D prime, E prime, F prime, G prime. Does that make sense? Okay. Did you have to name the first shape D, E, F, G? No, you could have named it F, G, D, E if you want. Doesn't matter where you start, just go clockwise around your shape. Okay? All right. Sorry, it's going slow. Now, directions on these. It says identify the transformation. Are we on a coordinate plane? No, these are easier then. You do not have to give me any of the specifics. You only have to tell me reflection, rotation, or translation, and that is it. You don't have to name the center, you don't have to tell me the direction, you don't have to tell me the angle, you don't have to tell me the line. Just name what kind of transformation it is. So when you look at blue to red, because that's our prime notation, do you see a translation, reflection, or rotation? Translation. But do notice the directions do say also use arrow notation. So again, it's kind of tedious, but it's not hard. So we're going to name this as, how do you want to name the blue one?
M-P-O-N.
Thank you. M-P-O-N, arrow, and then it'll be M prime, P prime, O prime, N prime. That's what they mean by arrow notation. All right, part B, what do you see going from blue to red again? Everybody sees a rotation? All right, good. It is a rotation. Again, that's all you have to tell me if it's not on a graph. So don't make it harder than it is. And then arrow notation, what's the first shape? Okay, and again, it doesn't matter how you name it, as long as you're going either clockwise or counterclockwise consecutively. So I heard XYZ, but I also heard ZYX. It doesn't matter. I'll do ZYX, arrow. What does matter is when you name the next triangle, that you use the same letters with the prime notation. Z prime, oops, Y prime, and X prime. But again, you could have said X, Y, Z and went counterclockwise, and that's fine. Any questions on anything so far? Okay. The next part of the notes are going to be where you have to graph the shapes, but I tried to save you time again, and I provided you with the graph. But notice up here on the board, there's not a graph. On the homework, they're not going to give you graphs of all of them. They're going to give you this, and you're going to have to make the graph. When it says, draw the pre-image and the image, I will be giving you points for your graph. It needs to be drawn, it needs to be labeled, it needs to be connected. Every year I'll have students who do this on their paper. And that's what they turn in. That is not going to get you credit. You need to connect your dots, draw your triangles. You need to label them, A, B, C, A prime, B prime, C prime, okay? So make sure that you label them. Then you'll get credit for your graph. After you graph it, then you're supposed to identify the transformation. Since you're on graph paper, do you have to give me the specifics? Yes, okay? But to save us time, I'm assuming that you can graph those, so we're just going to identify them. So look at your picture on the first one. What do you see? What kind of transformation? Reflection, very good. What do you have to also tell me besides reflection? The line of reflection. So what is the line that we are reflecting across here? The y-axis. Again, if you're not sure, pick 2 points, the pre-image and the image, and count the distance between there, and then go halfway between there to get the line that you're reflecting across. So there's 4 units, halfway would be 2. That means I'm going across the y-axis. And that is all you have to do on these. It does not mention arrow notation, so you're just graphing, labeling, and then identifying. Any questions? Okay, let's do the next one. Again, I should have given you the graph already. What do you see here? Okay, it is a rotation. Again, we're going to keep the center at the origin, always on these first problems. So you're going to say rotation about the origin. And again, if you're not sure, you're going to do what I showed you with another piece of paper and physically try turning it until you're sure. It is a rotation about the origin. What direction are we going? Identify which one is your pre-image. Is it the one down here on the bottom or the one up here at the top? The one at the bottom, because it does not have any apostrophes, no prime notation. So you're trying to go from this blue one to this one. What direction is that? Counterclockwise. And how far do you think we're turning it? 90, 180, or 270? 90. And again, if you're not sure, remember my little trick. Pick a point like E, go back to the origin, and then go to E prime. What is that angle measure? 90 degrees. So then that will even help you identify better. So 90 degrees. And you have to tell me all of those things when you identify it. Okay, one thing we haven't talked about. If you go 90 degrees counterclockwise, what is that the same as? 270? 270 what direction? Clockwise. So you can go 90 degrees counterclockwise, or you could have taken this shape the other direction, which would have been clockwise, 270 degrees. Do you guys see that? So on your homework, I would accept either answer. You could say 90 degrees counterclockwise or 270 clockwise. Both would be correct. All right, last thing that's in your notes for today is they are going to focus on one special transformation and talk about writing rules. So when you see write a rule, or they give you a rule today, it's going to be about translations only, okay? A rule will look like this. I will be very, very picky. I will count off if you do not start every rule with X, Y, arrow. Every rule is going to start with X, Y, arrow. What that means is you're saying that you can take the coordinates for your pre-image, X, comma, Y. So each one of these, X, comma, Y, and you can map them onto the image by using this rule. When you take a shape and you translate it, you either go right or left, right? That means you're going to take the X coordinate and you're either going to add something if you're going to the right, or you're going to subtract something if you're going to the left. Does that make sense? When you translate, you can also go up or down. So that means you're going to take the Y coordinate and you're going to add if you're going up, or you're going to subtract if you're going down. So the rule can tell you what the new coordinates would be. So for example, if I had a point at 1, 2, I could plug those coordinates into a rule. 1 would go in for X, 2 would go in for the Y. And whatever the A and the B are, whatever numbers those are, I would just simply add those to my X and add those to my Y to get my new point. Okay, we're going to look at an example and see if it makes more sense when I show you an example. But this is a translation because to shift right or left, we're going to add or subtract. To go up or down, we're going to add or subtract. So look at this example. Everybody with me here? It says find the coordinates for the image of triangle ABC. It says find the coordinates for the image. So on your paper, this is what you're going to have to list. A prime's coordinates, B prime's coordinates, C prime's coordinates. They're going to give you A, B, and C in the picture. And then it says draw the image. So then you'll go to your graph paper and you'll draw the new image. Okay? So look at the rule that they give you for the translation. It says X plus 2. What does that mean we're going to do to every point on our graph? Okay, we're going to add 2, and what does that mean as far as direction? What direction are we going to go? Right 2, because we're doing it to the X. X is going to be left or right. If it's positive, we're going to go right. If it's negative, you're going to go left. Okay, look at the Y. What are we going to do to every Y point? We're going to subtract 1, which means we're going to go down 1. So you can work this one of 2 ways. My personal preference is just to simply take the points and physically shift them right 2, down 1, and then go list where they land. I think that's the easiest way. So I would take B and I would go right 2, down 1, and label it B prime. What are the coordinates that I get for B prime? What is the coordinate for B prime? -1, 3. So then I'll come over here on my paper and list -1, 3. Do the same thing for C. I'm going to go right 2, down 1, label it C prime. Where did C land? 1, 0. So then I'll come over here and say C prime is at 1, 0. Do the same thing for A. Right 2, down 1. Label it A prime. Where does that make A land? Negative 2, 1. So then come over here and list negative 2, 1. So now we've listed the coordinates. It said find the coordinates, so I'll be grading that. You've got that listed on your paper. And then it said draw the image. You've already got the points graphed. All you have to do is just connect them to draw your image. Does that make sense? Okay, the other way you could do it if you prefer is you could go through and list the coordinates of your pre-images. So for example, let's say point B here is at negative 3 and it's at positive 4. Then you could plug those values into this formula. Negative 3 plus 2, comma, 4 minus 1. I plugged the negative 3 in for x and the 4 in for y. What is negative 3 plus 2? Negative 1, and that's what we got for B. What is 4 minus 1? 3, and that's what we got over here for B. So you can plug each point in, but to me that's a little bit more work than just simply going right 2, down 1. Would you agree? Okay, last one I want us to look at before we're finished today. Just exactly the same thing. So look at your translation here. What is this rule telling me to do? Left 2, up 4. Is everybody with Chris? How did he know it was left and not right? Okay, because it's a minus. And how did he know it was up and not down? Because it's positive. All right. So then they want you to find the coordinates. So we're going to have to list J prime, K prime, L prime, M prime, and what their coordinates are for each one. So again, you could go and list the coordinates for J, K, L, and M and then plug them into the formula. Or what I think is easier, because you have to graph it anyway, since it says draw the image, you're going to have to graph it anyway. I think it's easier just to start with J and shift it left 2, up 4. Left 2, up 4. And label it J prime. What is our coordinate for J prime then? Negative 1, 4. Let's do the same thing for K. Go left 2, up 4. Oops. That's not correct because I only went up 3. Do you guys see that? So sorry. So it was left 2, up 4. So it's actually at negative 1, what? 5. My bad. So sorry. Okay, now do K. Left 2, up 4. So where does that put K prime? Positive 1, positive 5. Okay, do the same thing for L. Left 2, up 4. Where is L prime? 1, 0. And now do the same thing for M. Left 2, up 4. Where is M prime? Negative 1, 0. And then connect your points to draw your picture. So sorry. Mrs. Lashley. Yes, ma'am. Yes, ma'am.
Part of the interruption. I need seniors, last name beginning with
Okay.
E. Please go down to
Sure.
theater at this time. Seniors, last names beginning with E and S.
I will let her know. You bet. 351, right? Okay, you got it. Bye-bye.
I see the following students in the office.
Okay, guys.